Greetings everyone, I'm Mehzabien Iqbal. Today I'm going to talk about my research that is novel algorithmic framework for secure and energy efficient integrated sensing and communication system. Wireless is evolving from decade to decades, from first generation to fourth generation. Now we are into the era of fifth generation of sixth generation. Well, in that era, the application is increasing as well as there is a demand of artificial intelligence on devices. So that means on-device AI will be increased around 1.3 billion and mobile AI market will also blooming. And we are also moving forward to millimeter wave to terahertz communication because there is a high users demand. This actually necessitates to incorporate sensing in conventional communication strategy. Now the question is, what is actually integrated sensing and communication? Well, it's a joint signal and sensing system where it's going to share the hardware, spectrum, and waveform together. And since it's a shared hardware, it's going to reduce the cost and also it's going to improve the spectrum uses. That sensing our capability eventually improve the beam alignment as well as physical layer security design. This is one of the basic example of integrated sensing and communication system where the base station and doing their sensing and communication together in multiple users. There are also a lot of use cases such as remote sensing, environmental monitoring, sensing as a service, vehicle to everything. So that means that integrated sensing and communication will be the future for next generation. Well, so this is very exciting, and when something is very exciting, there is always drawback. For example, millimeter wave radar and artificial intelligence can eventually recover the speech from smartphone vibration. That is breaching the security. And the research from Samsung, it found that that sensing can be also increase the power, which means there is a increase of power consumption. So there is always a trade-off between security and energy efficiency. So if you want to improve the security, you eventually need higher power. And then if you want to use that limited power, that may compromise the security. So there is always trade-off, and my research is actually balancing this trade-off by reducing the computational complexity and maintain the quality of service. So in order to do that, I proposed unified algorithmic framework where the algorithm one is the game theoretical Bayesian belief-based Stackelberg leader follower ISAC controller, where leader the ISAC base station and follower is the nodes, and the algorithmic 2 is the adaptive sensing and beamforming, where it's going to take decision whether the user will act as a legitimate user or friendly jammer. And then if it's a legitimate user, then there will be a secure communication, and if there is a probability of eavesdropper, then that user will act as a jammer and provide that jamming signal. Moving forward, we actually validate this framework by doing some numerical analysis, and that result was pretty amazing. 35% increase in secrecy rate, success rate exceeding up to 98%, and runtime reduced up to 12%. And we did that in millimeter wave and terahertz frequencies, and we also validate in practical scenario by incorporating SDR testbed as well as DRL optimization. To conclude, I actually introduced the necessity between trade-off of power and security. I propose the unified algorithmic framework, improve the secrecy and power, and then we validate this framework in real time as well. Thank you so much.